Hey guys, so based on some feedback I was getting in my last video, I thought it would be interesting to compare the performance of a Kabylake CPU and a Ryzen CPU when playing Quake 2 in software rendering mode. Some of you guys might not remember this, but games didn't always used to be GPU accelerated. Quake and Quake 2 both shipped with support for 8-bit software rendering, and it was because not everybody had a 3D GPU. So in my last video, we did a comparison of Quake 2 in OpenGL mode. And mostly I just did that because I wanted to illustrate kind of how absurd the argument was that Ryzen is a terrible gaming CPU. I know that this has been a thing on the internet lately. And so that was just kind of meant as a joke. And I know a lot of you guys found it hilarious, and I appreciate the feedback. But on a more serious note, you guys were actually interested in comparing the performance of the software renderer, and I thought that was a great idea. So today we are going to look at two different flavors of Quake 2's software renderer on both a Ryzen 1800X and a Kabylake Core i7-7700K. So the first one that we're going to look at is the built-in Quake 2 software renderer, and we're going to look at this on a Kabylake Core i7-7700K. So you can see the default resolution when you run it in software mode is 320 by 240. Remember, these used to be cutting edge 20 years ago. But anyway, so if I bring up the console, and I'm going to type SW_mode space 9, and that's going to bring us into a higher resolution mode. This is 1600 by 1200. Next, I just need to type time demo space 1 and press enter, and then hit the tilde to dismiss the console, and that starts the benchmark. And the result for our Kabylake CPU is 140 frames per second. All right, next up is the Ryzen 7 1800X, and you can see it defaults to 320 by 240, so let's set it to 1600 by 1200 and start the benchmark. All right, so the Ryzen CPU scored 122.2 frames per second. So this gives Kabylake the win with a 14% lead. But remember, the Kabylake here is boosting to 4.4 gigahertz during the benchmark, and the Ryzen CPU is locked at 3875. So this gives Kabylake a 13.5% clock speed advantage. And what this tells us right off the bat is that the IPC is basically the same. There's a slight edge for the AMD processor. It looks like it's at 2.32 instructions per clock, while the Skylake processor is at 2.30 IPC. But you can see that because of the higher clock speed, that the MIPS is much higher, on the Intel system. And so this just goes to show that AMD has actually got what it takes to be competitive, in single-thread IPC. It's just that they don't quite have the clock speed there to match Intel. All right, so let's move on to the second software renderer. This one is different than the built-in software renderer in that we are going to use an OpenGL software renderer. And why this is different is, well, let me explain how this is different. The built-in Quake software renderer has several optimizations to try to improve performance by sacrificing image quality. So specifically, the Quake 2 renderer does not include per pixel perspective correction. So there's actually a little bit of warping that's going on the pixels. It does not support bilinear filtering, so it only uses aliased pixels. And it also only supports 8-bit color, so there's no colored lighting. This OpenGL driver that we're about to use has all of these things. So we're going to use this and kind of compare how it does. The only reason that we're doing this is because I wrote the renderer. This is something that I did back in 2003. So I know how this software works front to back, and I wanted to use it because I optimized it on an AMD system. In other words, at the time that I was doing this is back in the era of the Pentium 4 NetBurst and the Athlon XP, and maybe the Athlon 64 came into the equation about that time. But anyways, I had some green printed. This is back when we had books, AMD optimization reference manuals, and I used those as my guide to try to optimize this software. So it uses C++ at a higher level, and then for the pixel rasterization and the triangle processing, it uses SSE and MMX. So we're going to look at how these two CPUs stack up when using this software as opposed to the regular software renderer. Okay, so first up we have the Kabylake computer, and what I'm going to do is I'm going to go into the video options and I'm going to change it to use the default OpenGL driver, and then I bring up the console and I type GL_driver space SGL, SGL being the name of my software renderer. And then I type vid_restart, and then that brings it into, it's now in OpenGL software rendering mode. And then I type time demo 1 to start the benchmark. And so you can see this is going to take a little bit longer to run than usual because the frame rate is a lot slower. And before you guys make fun of me, you know, remember this is actually really fast. It's running in 32-bit color mode instead of 8-bit color mode. It's doing per pixels perspective correction and bilinear filtering, so it's doing a lot more work on the CPU than the default Quake 2 renderer does. Alright, so the Kabylake computer scored 15.3 frames per second. Let's move on to the Ryzen 1800X. Alright, switching the video driver over to software OpenGL and starting the benchmark now. So if you keep your eye out, you'll probably notice a couple of rendering glitches from time to time. And this is because, I mean, my software renderer is not perfect. There was a couple of bugs that I never quite got ironed out. You'll notice that the gun is clipping on the front plane because I didn't get the front plane calculations right, and also sometimes when the particles are on the screen, the alpha is not working correctly. But it's the same on both systems. Like, there's no difference between the two, so it's still a fair benchmark. All right, so it looks like the Ryzen system has completed, and the frames per second is 22.0. So that's what is that? 45% faster than the Kabylake CPU. So that's a pretty significant outcome. And so I think anybody who tries to, anybody who wants to argue that the Ryzen CPU doesn't have the IPC that Kabylake does, is not informed. Let's just put it that way. And let's zoom in to the I was running status core during both benchmarks, so let's take a look at that and see what it says. So what I did is I went back and I scrubbed through the video looking for the peak IPC, the highest IPC that I could find for each of the contenders. And on the Intel system, we have a peak IPC of 1.7, and over on the AMD system, we have a peak IPC of 2.59. That is, as you can see, that is quite significantly better than the Kabylake processor. Now, it's not sheer luck or random chance that this software is optimized better for AMD. It was optimized based on the principles that AMD laid out in their optimization guide about how to use their hardware more efficiently. And one of the big things that AMD does that gives it an advantage is in the instruction decoder. It doesn't have this limitation that Intel does. Intel has a limitation in their instruction decoder where it can handle up to one complex x86 instruction, but then the three other instructions in the pipeline have to be simple instructions. On the AMD pipeline, at least back in the day, that was not the case, and I also believe that is also not the case today with the Ryzen CPU. So that gives it a pretty clear advantage to be able to utilize complex x86 instructions on all four instruction decoders in a given clock cycle. All right, so we're just about to wrap up the video. Let's just say in closing, it looks like the Zen architecture is very, very promising, and I look forward to seeing more optimizations in more software packages by other developers. I know that's going to take some time and it's not automatic. AMD definitely has a challenge in front of them, but there is no question in my mind that the Zen platform, the Zen microarchitecture, is one that can compete with Intel. And hopefully we can see this competition leading to better products for everybody. So anyways, thanks for watching the video, and if you want to see more, be sure to subscribe. I will be adding more videos from time to time, and thanks for tuning in. Goodbye.